Cool. 517, super washing machines. You have n super washing machines on a line. Initially, each washing machine has some dresses or is empty. For each move, you can choose any m, where m is between 1 and n, 1 to n, washing machines and pass one dress of each washing machine to one of its adjacent washing machine at the same time. This is one of those problems that have no relations to real life. Given an integer array representing the number of dresses in each washing machine from left to right on the line, you should find the minimal number of moves to make all washing machines have the same number of dresses. If it is not possible, return -1. Okay, let's see. Okay, okay, okay. Seems maybe straightforward. I think you just do like a linear scan, and then either divided by 2 or something like that. Uh, I'll explain that at the end. But if it happens to be right, if it's wrong, then you know. I should name my stuff better. I've been doing a couple of contests, and so I've been shortening my variable name, which is not great for interviews, obviously. So definitely, I mean, I'm not as time constrained now, so. Turn -1. Okay, otherwise it's always possible. So let's just say go is equal to. Is this a heart? Maybe I'm gonna get weird by it. It's something like that though, but because let's say this one, right? It needs 2, so it will get 2 from the next one. So you just plus 2, and then this one you need 3, and that's 5. Look at the move first. I think this part is valid no matter what, but at the same time, okay. I mean, it doesn't make sense for numbers to go on the way. So is it just like to the farthest? You could do it at the same time. Oh, this does happen at the same time. Excuse me. If I underestimate this one a little bit, let me see. Play around with it. There's some like weird propagation E stuff that I feel like that I don't know, that reminds me of something, but I don't have a great articulation around it. But I don't think this is right, but I'm just seeing. Well, that's just odd, but you would do that. Oh yeah, I mean, of course, that makes sense, actually. Let's put up some test cases. Let's just say 11. And math is hard, so I should do something more basic. I think that's -1 then, because I did my math wrong. Did I quit? Isn't that what I clicked on? So I think the way I'm counting, the reason why this maybe works is because the way I'm counting, it propagates it forward. It's almost like because I think the way I'm thinking about it is when you see a current machine, you're just moving negatives instead of pluses. So you know that you're going to have to take x stresses from the one next door, but I don't know that I factor in the simultaneous part. So that's why I feel like, to be honest, a lot of this is just gut in that, like, I feel like I've seen something similar before, and that's why I'm doing this way, but I can't prove it to myself or to you guys. So because if you could, so the first washing machine will just take one move. Why does this take 3? Well, how did I get 3? No, because this one takes 2. All right, I'm just gonna submit and then get a wrong answer so I could see where I'm. Because I can't come up with a good case. Okay. Okay, so this is finally, because I keep on thinking about one generator, but this is now a case of 2 generators, so the simultaneous part finally comes into play. Okay, I'm happy that this problem is not as silly as it is, but well, I thought it would be, because I just couldn't. I think from one machine, maybe that's true, but yeah, because if you just even remove one side of it, or maybe even just make it just 2. We do this, then I would. Yeah, oops, I can't do math. Okay, so that's right, but for multiple addresses, which I think actually, because it never makes sense for addresses to cross, right? So I think there's probably ways to kind of break it up to one problem. If that makes sense. Like a combination, like a linear combination of multiple problems, and I think that would probably figure it out. I think that's how you would solve it then, but that's a easier set statement than done. Because what does that mean? Um, hmm, Something like max. There's something that resets it, but what is the resetting condition? Hmm. Hmm. This is right. Well, that's not true, I guess. Oops. Well, I don't return the right thing, so. Okay, okay, okay. Oh, hey, Philip Destroyer. Welcome to stream. Hope you have good luck on your results. You know you had it already. uh, this is the only case where I want to go left and right on the same one, which this does not take account. Hmm. Oh, wow. You mean like literally just had an interview? That's huh. I mean that's I don't know intense, but I mean I said that as I'm doing Leetcode, so. But yeah, still good luck. Uh, I thought you mean like recently, but um, hmm. I don't know if I'm just hacking now, to be honest. It's missing. Oh wow, I mean that's great. Yeah, I mean that that at least should get you over the initial pause. So I think that's it, because we know that was maybe that's the way to think about it. Because if because at the peak, I'm gonna try something again and maybe see if that's right. Oh no, well, hmm, and this is one of those. I think I don't have a good intuition about this file. Uh, that's and I do 4. 35, so 7. Definitely need something. Oh, So I guess that's a case where you get two at the same time. Man, this is one of those things where it's going to end up being a brain teaser. But I am discovering the edge cases very closely, one by one. I guess something like this. Hmm. Yeah, good luck. Definitely. Uh, there are a lot of great companies out there these days. Definitely for everyone's interests. So, maybe it's the other way. Yeah, I gotta change this then. I guess it doesn't matter actually. It's just a difference, right? Uh, hmm. This one, yeah. 7 says 2. Oh, gives them 2 steps and 3, 4. They're like -4, right? How did I get 6 on this? 1, 2, 4 moves. It would get. Oh, it brings us 6 because this is large, but maybe this doesn't have to be apps actually. Hmm. Now that I think about it, because I think because it thinks it's 6 down, that's why it's doing it. Hmm. You could still see the look on my face because I okay. I mean, I think I got some signs incorrect assumption, but I think mostly it was okay. I think yeah. I mean, I thought I had it in perfectly, but I think so. Yeah. So the reason why I kind of went down this route, I think, or at least some of that was intuition. I mean, I think some of the initial like this photo makes sense, where like if you can't do it, you just can't do it if it doesn't divide equally. And then for me, it's about looking at the the peaks, um, because I think it's natural to kind of look at each. Or my initial thought was to kind of look at each machine that needs stresses and kind of try to figure that out, which is why I got goal minus stress, I think. Um, but I think what you actually want is the other way, where like, okay, for each dress or for each machine that has too many dresses, well, they have to go somewhere, right? And it'll take at least that many turns to go there. So that's kind of how I came across this. I don't think I've explained it that well though, because it's still a little fuzzy in my mind, to be honest. Um, because there is 2 goes here, so it's now this is 4 because it knows that in 2 moves this will be done. So then adds a little bit more because then it carries the one that's far away. That makes sense. I wonder if you could. I wonder if there's a mathematical property somewhere where you also have to like. Still, I think the kind of weird-ish intuition is like. Is there a thing where like this? How does that work? I mean, obviously it works, but it notes that like how does this only one? Oh, okay. I think that's the part that I got a little confused about, or at least thinking of, but now that makes sense. Because I think what I was thinking of is that okay, there's the two, so it carries one like it takes I don't know 6 or 7 turns to get to the beginning because you just have one dress, and then now like the two is here. But what actually happens is because they all happen at the same time, uh, the last machine passes to the second to last, and this the one like everything shifts over. So okay, so that's why the peak thing works. Okay, okay. I mean, I think to be honest, I think some of that. This is a very hard problem. I had to submit 3 times to get wrong answers to kind of get clarity. I think some of that is that to be honest, like some of that is just gut feeling and that is intuition in and working backwards because it's something that I felt like I've seen before. Maybe not this particular problem, but something similar. I think that's something that you get from just doing a lot of practice and you see me just get this a lot. Yeah, and this is definitely very would be very annoying on an interview because as you kind of listen to me, I don't know if I could articulate it that well. Like the reasons why, like I could like yeah, I mean, knowing the answer or knowing the code, like I could explain it a little bit and maybe pretend I know a little bit more than I do. And I think now that with this case, I do have a little bit more of an intuitive sense because I think I was just not, I didn't have that light bulb on where like, well, if it already reached what it needs to be, then it just doesn't move, right? Um, there are a couple of other kind of invariants in there as well that I kind of thought about, but maybe I don't think I talked about, which is that, for example, um, for each given washer, all the dresses will only go in one direction, meaning like it makes no sense for like dresses to cross, right? Which I think is obvious-ish, but it's something to think about, and that's why like some of this you can do in of n time because it only floats in one direction, and because it only flows in one direction, you could actually propagate the negative dress forward, uh, if that makes sense, versus like passing a positive dress backwards. And that's how this thing kind of makes sense, I think. Um, but yeah, it's and I definitely please keep on asking questions if you want me to keep on explaining it. I feel like I'm saying the same thing in different words, which is not no value. It's just there's some value in that, but I feel like I'm I don't know how much convincing people would need in general because I don't know if I'm that convinced. I think now I'm more convinced than earlier, but but definitely a tricky one. I mean, I would say I like, I mean, well, yeah, I mean, don't get me wrong, I would hate to have to see this on my interview, like when I'm interviewing. Well, maybe not now because I know the answer, but in general, uh, but I like it as a brain teaser because it's kind of like I don't know, there's a lot of like deconstructing from stuff. I mean, it's not a great interview question also because like the coding is very short, so you don't get a sense of like someone's coding values. Like this is literally like a for loop, which you could debate the merits of that because like for dynamic programming, you can always say there's always for loops, but at least in that, like you really have to understand it. But yeah, I mean, I would like to kind of look at the answers later, yeah, I mean, I this is one of those brain teaser problems that like if you get an interview, sometimes you just kind of do the best you can and um, you know, try to grind it out, try to like get hints and kind of figure out step by step. I think on this one, the good thing about that part, at least in terms of working toward a solution, is that there are probably a lot of hints you could give, and a lot of them don't click unless you have them together. So maybe that's a good thing, but I don't know. That's not my style. Probably would never ask this, but It's a very fun problem, though. I don't know. Yeah, that's what I have for this one. But yeah, cool.